Hi, this will be a video about cantilevers and finding the reaction forces on them. Now in this scenario we have a diving board and we were also given the weight force of the plank and the weight force of the person standing at the tip, which are defined by big mg and small mg respectively. So next up, let's draw the free body diagram. So we're given the distances between each force in green, and we also have our reaction forces going upwards to support the plank and the weight forces going down. It's also good to note the locations of the reaction forces, since that's where we'll be summing our torques. So we'll call these point 1 and point 2. Next up, let's draw our axes. So over here, the axes represent which direction the horizontal direction is and the vertical direction. So in the vertical y direction, the upward forces will be positive and the forces going to the right will be positive. But of course, we don't have horizontal forces in this case. Now we also have to define the direction of the positive torques. So in this case, we'll say that going anti-clockwise will be positive. And we also have our given values written down here. So first of all, we should always begin with Newton's second law, which is F equals to ma. But of course, our cantilever here is not moving, so the sum of our forces should equal to 0. So when we sum all of our vertical forces, we end up having R1 plus R2 minus big mg minus small mg equals to 0. So let's call this equation 1. Next, we should sum our torques, and this is actually the same as just saying the clockwise torques equaling to the anti-clockwise torques. And we'll do this around point 1, so right at the left tip of the board. So we'll take the torque around 1 at 2. Oh, sorry, let me rephrase that. We're going to have the reaction force 2 going around point 1. So the perpendicular distance of the force here is 1.5 meters multiplied by the force at that point, which is R2. So we have R2 minus 1.5 as our torque there. And this is going anti-clockwise, so it's positive. And let's get our anti-clockwise torques now, which are going to be big mg and small mg. So since they're clockwise, we're going to define them as negative torques when we're summing our torques together. So the perpendicular distance of big mg is 2.5 meters. So we're going to have big mg multiplied by 2.5 minus mg and its perpendicular distance, which is 5 meters. So we have minus small mg times 5, and all of this is equal to 0. And now we can just simply arrange R2 to make it by itself and sub in our given values in the bottom left. And when we do the arithmetic here, we should end up with R2 equaling to approximately 2,416.7 newtons to 1 decimal place. Now, are we done? Not quite yet. We still have to find R1 in this case. So let's just sub R2 back into equation 1. Now when we do this, we're just going to sub in our big M and small m values again, along with G of course. And so we have the sum of our forces here equal to 0. Rearrange R1 by itself, just like we did for R2 before. And we end up with negative 1,616.7 newtons. Now it's also good to note the negative sign here. But what exactly does this mean? So when you have, force is a vector quantity. So when you have a negative force, you're essentially going the opposite direction. And on our free body diagram, we defined R1 as upwards. So in this case, we have R1 as upwards in our free body diagram. So when we account for the negative force, it's actually saying that the reaction force at point 1 is actually acting downwards onto the plank. But is the reaction force at the tip of a cantilever always acting downwards? So the short answer is no, and we shouldn't generalize this case. So let's consider the following free body diagram. Now we have the weight of the plank going in between the two reaction forces, or the two supports. And if you draw arrows for the torque of big mg around point 1 or point 2, it's always acting in between them two. So what this is trying to say is that the plank will never actually tip over. And if the plank doesn't tip over, that means that there will never be a reaction force pulling downwards onto the plank to keep it stationary. Therefore, both R1 and R2 should be upward reaction forces. And that concludes this video on cantilevers.